Okay, I'm going to start. So this lecture or this particular special session, I'm trying to go through the whole code for the first reference implementation for homework assignment number 3. So let me just create. Let me see which directory it is. Okay, good. All right, it's here. So I'm going to create a directory called this one. I will call it office hour. What time? What day is today? November 5th, right? Okay, cdoh. I'm going to start it from scratch so you know what I'm doing. So this is an empty directory, but I have the reference implementation on top of me. So I'm going to do a tar zxvf / ecs36b. It's f2021 homework 3. Okay, so I'm actually extracting all the file. That's the directory. So I'm going there. So this is the file you have. So let me actually, before I go to the code, let's actually try to run it. And if we run it and then we see how the different parts of the program respond to that action. So you just type make. Assuming you've done part 1. In fact, if you can actually run this program, you know your part 1 is actually done for your program. So I actually create hw3 server, hw3 client. So I just create another window. Okay, so this is window. I'm going to run hw3 server. Okay, server is running, and then I'm going back to hw3 client. So when I run client, you can see that it's actually called get distance. And on the server side, you actually see that there are 2 get distance call that's actually being received. Okay, so now I have seen the action. Now I want to show you the code. So the first thing it does is I'm going to look at hw3 client.cpp. So client.cpp, you can see that it's a very simple program. What it does is create 2 shadow fly objects. And then what I really doing is just call this f3, which I create a shadow fly object. I just say f3.getDistance. And I create another fly object called f2 that's just get distance. So essentially what it does, the real object for this 2 fly object is actually created on the server side. And the local version on the client side is just a shadow. So let's actually go to the server side. We can compare the code. So on the server side, if you go to the main program, you can see this is very similar, by the way, to your homework 2, but not exactly the same. So I actually have this 2 fly. This object called fly2 is being declared here. This is a real object being created here at this line, and then another object being created here. So that's basically the 2 objects I created. But what I did the hack here is that I defined 2 pointer called f2 and f3. I put the reference, which is address of fly2 and fly3 into f2 and f3. So essentially fly2 and fly3 are real objects, but f2 and f3 are basically the pointer to those 2 real objects. Okay, now let's see where is f2 defined. f2 is actually defined, you can see it's defined as a pointer to the fly. And why I'm doing this, I'm essentially do a hack to do a global variable, but in a real world application, you probably will put it in an array or something like that, or a vector, but I'm just trying to show the minimum. That's why I just create 2 global variable, f2 and f3. So let's actually look at this particular function called ecs36b homework 3. And you can see that inside here, what I check the class ID if it's a fly, object ID if it's 00002. If it's equal to 0002, I'm actually going to call, if it's a 02, I'm going to call f2 get distance. If it's a 03, I'm going to call f3 that get distance. So that's how the server side get called. So essentially what I'm saying is that from the client code, when I do f3 get distance, it's actually going through the shadow object code, which I'm going to show you. And eventually it will be connected to, sorry, can I move this over here? Eventually it's going to connect it to this part of the code. So if you do f2 get distance, it's actually going to be called eventually on the server side on this code. And then if you do f3, it's going to be there. Let me just modify and then tell you the result. Okay, so let me actually change the code here. Just modify this a little bit. You can actually sometimes add this statement to make your code, make sure you understand your own code a little bit better to know what's going on. So I'm going to actually print out something. cd cout, no, 2 : sorry. I would just say this is hw3 server calling f2 get distance. Okay, I'm just calling this and then \n like this. Just add a line. And then here I'm actually doing the same thing, but this is I'm actually call get f3. This, let me put a few more f so it's make it a little bit different. Okay, I'm already save it. Now I'm going back to here. Let me kill my server. I kill my server, and then I can do just make again. So now it's recompile the server, and now I'm actually run the server again, and then I'm actually run the client again. The client side is the same, but now take a look at the server. The server now print a new message, hw3 calling ff3 get distance, because the first line I call, let's go to the client code. The first line I call is actually calling f3, right? f3 distance. Then I call f2 distance. So you can see that on the server side, actually, I just print out the message. So I know exactly the call is actually eventually reached to that part, that portion of the code, which I show you over here, right? So you see that I just show you how the code connected. All right, so this is the most outer layer of the action. The outer layer is here. I call f in the hw3 client.cpp. I make this two call. At the receiving end, hw3 server, I actually receive those two call, and I'm calling the thing. So now the only remaining two things I like to explain is that how did this happen in the middle? How did this everything happen in the middle? And also I want to explain to you a little bit about, I think this part you should be fine. f2.get distance is just calling whatever f2 and f3 is. And in this case, we actually know f2, f3, they are real object. They're both real object because the way you construct this, they're real object. But however, you can actually even change one of this to a shadow object and make one of the fly to be on hw3 another. That's a more like the enhanced implementation. You can actually develop that scenario. But once you understand what I'm showing you right now, you should feel comfortable to do whatever you want. Okay.
Yes, sir. What's the reason for flight
1?
one?
Well, it was probably just historical lift there. I never use it actually in this particular example, because I'm actually just, when I develop this code, I just copy the HW homework 2.
Oh, okay.
And I just shuffle it there, make some small changes to make it I want for it. So essentially you can see that it's very similar to the homework 2. Homework 2, whatever that CPP. Okay. Any other question before I
pass them in as reference?
What?
Like, why did you create the pointers, the flight?
Okay. So how do I actually access to this variable?
Which one?
This 2, fly 2 and fly 3. They are local variable that's actually belong to this main function, right? So essentially this memory will be exist, but this 2 variable is only accessible within that scope of a function. I mean, how do I actually access those two variables from the other function? Because the program is interesting in the hw3 server.cpp. This part is actually just executing until it reaches this point called listening. When it's actually doing start listening, the program actually stopped here. And whenever you have an incoming request from remote procedure call RPC, it will directly call that function that we declare a little bit earlier. So this basically just to let you know that when the program reached this particular phase, it will actually stuck there. It's stuck there, it's just listen to any incoming request. This is a server. The server is receiving internet packet from anywhere with the same port number. The port number is 8384. It will receive that, but then any matching the port number is going to be received by this function. So you can see that this function is never being called within this program. This function is only being called when you make an RPC, remote procedure call. So the main function never called this function called ecs36b. So essentially, think about what's happening. This program, it actually stuck at the start listening. Means it's listening whether there is a request to call this function. Okay, is that clear?
So this basically when you call it and require the JSON and JSON values afterwards. The ecs36b function.
This is the function. I'll go that a little bit detail, but this function is called every time you make a remote procedure call from remote. Yeah, but I will actually change this name a little bit later. Okay, I actually want to follow up on your question. Thank you for that. And then I'm going to actually move a little bit deeper. So now I'm actually going back to the middle. How does this happen from the client connect? And the first file I would like to touch is ecs36b. So this is a file that's actually generate all the protocol. So for the final product of your homework assignment number 3, you're going to have 4 of those, but I'm actually going to change this. I'm going to change this to, let me see. What's your name?
Lakshita.
How do I spell that?
LAKS.
LAKS HITHA. Is that the right way to pronounce it?
Yeah.
How do you say that again?
Lakshita.
Lakshita. Okay, that's a very, very nice name. I like that. I hope I can learn the right way to pronounce your name. Okay, so I'm actually going to change that function call to Lakshita.
Yeah.
Okay, that's the name. Okay, so I'm actually going to change that. So okay, this is the new JSON file. Now I'm going to do make again. Okay, I'm going to generate make, but it says there's something I didn't implement. I'm supposed to implement a function called Lakshita, and I didn't. Okay, that's no problem. I will tell you why. So let's actually take a look at what the code it generates. So that's why I want to see hw3 client.h. There are 2 files that generate hw3 client.h and hw3 server.h. Let's look at hw3 client.h. Inside this function, this is function, I hope you understand every single line. So I create a class called hw3 client, and you see that now the function name, instead of called ecs36b, now this function name is called Lakshita. Okay, now I change the name. So your name becomes the function I'm called. You can change this to get distance, to operator equal. It's just a name. So I actually changed that. So now the remaining code is the same. And then when I call this method remote, the name of the function is Lakshita. Okay, so that's the function. But in order for me to use this code, I have to change this code. So what I need to change is in the shadowfly.cpp. Inside shadowfly.cpp, guess what? Over here, I have this code is also generated. Over here, this code, instead of ecs36b, I have to change to Lakshita. I have to change that. Okay, this will help me to compile shadowfly.cpp correctly. So let me just tell you that make shadowfly.o. Now I can compile successfully because match. Okay, so that's the client side. That's in fact the only thing when I change the name, that's the only place I need to change in the client side of the program. And then I'm actually going to deal with the server side. So the server side, I'm actually going to show you first the hw3 server.h. This is also generated. You can see that this function now has a function called Lakshata, and then I have a virtual function inline, but the most important is this line. This is called pure virtual function. It says equals 0, means that it's expecting whoever used this class definition will provide a real implementation for Lakshata. So now I have this line, and now the difference is I have to look at hw3 server.cpp. So in the hw3 server.cpp, let's check. Number one, I actually define a class that's inherit from hw3 server. Where is that hw3 server? That's actually being defined in hw3 server.h. You see it here is hw3 server.h. I define this class, but now I'm actually defining a my hw3 server, which is inheriting from this one. And so inside here, I'm actually going to have an inconsistent because this code is generated in the bottom. This code on the top is actually I provide the code. And you can see it's already mismatched because here I'm still using ecs36b. So I'm actually going to change that to Lakshata. Is that the right way to? Okay, I'm getting there. I'm actually remember your name. You're in trouble, okay? Just let you know. All right. So now I change the name, but then I have to do is this part is fine. Constructor shouldn't need to be changed, but this function need to be changed. Is that right?
HI.
Ah, okay. Thank you. Okay, so now if I change, I think this is the only place I need to change. Let's try to make it again, make it plain, make. Okay, everything is working. You see that what I show you is I can change the name of whatever I define, but I need to modify I need to modify shadowfly.cpp. I need to modify hw3 server.cpp. I get it to work again. Okay, so that's basically the power of this file. This file. So this file is very critical because this file determines the code that's generated to allow the client server going to communicate with the correct name. If it's ecs36b, then both sides has to be ecs36b. If it's Lakshata, both sides have to be Lakshata. They can communicate. Okay, that's the name. But that's why I'm saying that if it's homework 3, we're going to have 4 different functions. Then we're going to have a 4 different names, 4 different sections. And with, of course, number of parameters. Okay. All right, so now I'm actually going to go through the pipeline. So you understand this part, you understand how code generate. Let's actually go through the code from the left side to the right side. So I'm actually going to do this part first, going to hw3 client.cpp first. So hw3 client CPP is the driver of the whole scenario. This is a really simple, oversimplified, but it gives you the concept. You can extend it for your final scenario. So I'm just only look at one line, which is this part, f3.get distance. Okay, so I want to ask you, when I call f3.get distance, where is the code, or where's the function that you think that in this situation that this f3.get distance is going to call? Which file is going to call which function? Where's the function that this will lead to? No, the immediate code. The immediate code. Yes, shadowfly there's only, in fact, let me tell you that there's only two places have get distance. Grab, get, no, it should be get distance. There's only really two places you can have get distance. One is in shadowfly.cpp has a virtual function. One is transaction.h, which is if you do CPP, there's only, I mean, the client is just calling, so it doesn't count. Server doesn't count, but you can see that there's a shadowfly.cpp has get distance, and there's a transaction.cpp has a fly. So there are essentially two different versions. One is shadowfly colon get distance. One is a fly colon get distance. There's only two places it can go, right? So now let's go back. So which one do you think this get distance is called? The fly version or shadowfly version? Shadowfly. Because why? Because this one is created as a shadowfly. Okay, so that's the definition of virtual function. It's created. So now the next function is going to call is shadowfly.cpp. So let's actually go to. So now we're here in the shadowfly. We know it's going to call here, not this one, right? This is the code that's going to execute. So now, so that's why I want you to take a look at this piece of code. Okay, so in this code, there's a few different places you need to be careful. One is essentially, there are three issues. Number one is there are some facility code you need to have in order for you to exercise the JSON RPC protocol. There's another piece of code is essentially handle how do you actually use JSON RPC to actually communicate to the server side. And the third piece is how do you actually handle the result from, there's the three things. Set up the RPC pipeline, send the message over there to the server, and process the result received from the server, right? If you have this three, that's complete action. So let me actually tell you the first part. The first part, the set up the facility, is just this two part. This two part is essentially set up the HTTP client because we're using HTTP protocol in JSON RPC to communicate with the server. You have to set up a client at this moment. And then you have hw3 client. I will actually talk about what is hw3 client. Okay, let me actually first guess. Where do you think hw3 client was defined, was declared or defined? Where do you think that particular file is that particular class? This is a class, right? I have a class called hw3 client, my client, whatever. Which file do you think this class was defined? Yes, exactly. hw3 client.h, that file is what? Automatically generated. So it's basically generated the code to support this framework. Okay. All right. So this two line is essentially just for you to set up the pipeline. Okay. Just to set up for JSON RPC. I will call it JSON RPC setup. Okay, all right, now this part is actually, I would say the second step I mentioned is prepare of sending to the server. Sending the request to the server. Okay, you can see that what I did is I actually create something called my V. You probably know that my V is just my JSON value, my JSON object. That's just a very common name. Not only me, but a lot of programmers.
Yeah, my V is an object of JSON value.
My V, yeah, this is a class. This is a class. JSON, under the JSON, there is a class called value. And then my V is a variable, like an integer I.
Okay.
So that's the type. This is the variable name. It's an object.
JSON value is a type.
JSON value is a type, yes.
So what kind of type is that? Is that
Object. It's an object. It's JSON. JSON value is the most common type. I mean, when you deal with homework 5, you actually will learn a lot about JSON value because like this morning when I show the code, I'm using this type a lot. This is primary data structure. Let me actually show you a picture. You can actually see how things works. I should probably refer you to this link. Let me see, JSON. Either way, use Google helps a lot. CPP, JSON value, CPP, and it will teach you something called JSON value class reference. Under JSON class reference, you actually have this whole picture about everything you can use with this value. You can see that this is its object diagram. This is JSON value. You see that I have a different, sorry about that. It flipped. Let me show you a few things. This is all the member function. You can have an operator. Yeah, look at this section. We talk about this as string, as C string, as in, as int 64, as float, you get as double, as bool, and it's null. Remember, I use all this as something or is something.
These are all inbuilt functions of that.
This is all member function.
Oh yeah.
This is all member
These are all
function.
member functions of this class.
This class, yes. This is a C++ implementation of JSON object. So this is an object, this is a class called JSON value. And this is essentially all the member type and the member function. You can see that this has, if you learn this, essentially you know how to do JSON programming. Just this one single class. It basically, that's why dumpj and jdump is essentially, dumpj is convert your C+ object into a JSON object like this, which you will know in homework 5, okay? All right, so I'm actually coming back here. Any other question? All right, so now you can see that you have this value called myv, and now this is really the call. Sorry about this. The real call is here that you have a my client that you define here, hw3 client, my client, and you call this function Lakshata. And this function is provided whatever parameter that's actually matching the one. So here is a tricky part you have to know is that in this function, Lakshata, I will actually show you, let me first show you what this function was declared. So you will know why I'm calling it that way. hw3 client.h. Let's look at client.h. I define class hw3 client to public JSON RPC client. Okay, so I'm actually creating a special instance from the standard JSON RPC client. I have a constructor, and I have this function called Lakshata. Let me move this a little bit here. You can see that let's count how many arguments you have. This argument has argument. First one is action 1, arguments 2, and then class ID 3, and host URL 4, and object ID 5, and then owner VS ID 6. Okay, there are 6 arguments and putting in this way. So 6 arguments, and remember this code is what? Automatically generated, right? So where do they actually get the 6 parameters? Yes, exactly. Thank you. Let me just.
So the SP say JSON in the form of television handling is actually the homework 3 JSON file.
Say that again.
So we have in the homework description there's a SP say JSON file, and that's actually the homework. This
That's part 1.
Oh,
Spec that was a part 1, not part 2. So you look at the part 2. Sorry, not part 2. This is the file you receive, and I changed this to Lakshata. But if you think about parameter, look at this: action, owner VS ID, host URL, class ID, object ID, arguments. Those 6 match those 6 we just saw. Okay, so they're actually getting all this name from here, the 6th one. Okay, so essentially this 4 represent the core object. Those 4 owner VS ID. The most important one, of course, host URL that will help you to know where that, but we also need to check class ID and object ID. Owner vs ID in homework 3, actually you can ignore that. Doesn't matter because we didn't set up to test it anyway. But the class I will explain to you what is the owner ID really mean. I mean, it could be that, let me give you an example. We talk about smart fridge, right? And I actually create 2 Apple objects or 2 beer objects, but one actually created by the wife, one created by the husband. Or whatever spouse, and therefore it might be 2 objects, but one of them actually we create a separation about which version you want to talk about. So we actually allow who's the owner of that. I mean, for example, I say I own the beer. You can actually ask it to that, but that's my beer, something like that. Okay.
Or is that just a placeholder?
Yeah, you can think about that as a placeholder. Yeah, that's correct. Okay. All right, so I'm actually going to do go to forego. Okay, we have this code. So now you know how is this function get generated from the JSON file. I'm actually not going in there, but I want to tell you this piece of code first because I haven't finished this code. So I'm going to call that my client. My client is generated by the okay, my client is here, hw3 client. The hw3 client was actually generated in hw3 client.h. So I'm going to call it with this 6 argument, and you can imagine those 6 arguments are given, and I know. And the first argument is I say it's action, so I just put get distance. The second argument is something, which I just randomly put a string. And now this 4 argument, it need to match one to the order. The order has to be correct with that. So you have to be careful about the order you put in here. They should be consistent with the hw3 client.h. So what I did is when I do a get distance, because it's this object, so it's this to the class ID dot C string. So for some reason that you have to use C string. There's a difference between string object in C++ and the traditional C string, which is a character star. And for JSON, for some reason, it actually has to have C string. If you remove the C string, compiler will not let you go. For some reason. Let me actually check. I never checked this very carefully, but I want to go to hw3 client.h. Let's see how it's defined. Wait a minute. That's interesting.
C string converts the things into strings, or how does it work?
That's actually very strange. In fact, I bet, I'm sorry that you removed C string. Let's actually try it. You know, I don't think I need C string because here is using string, the standard string class.
But I mean, what is the use of a C string?
Yeah, what does it do? Is it does it convert stuff? to
Yeah, it
string?
converts from the C++ string class to a traditional C.
Then what is toString though? Isn't the same?
ToString is no. ToString is convert, say, an integer to a string.
Okay.
Integer.
Okay, then what does this do?
This is convert a type from C string, which is, you can see std string. That's the C++ string. It's a string class.
So I mean, class ID and object ID are they like part of the
Yes,
C++
it
string
is.
class?
It is. So
we
I
can
don't
give an
know
example.
why. I don't know why I put C string, because C string essentially converted to character star.
I mean, can you give like a small example of a C string?
So what you learn, the string in ecs36b, that's C string. Whenever you say string,
So cat style basically.
is a character
So
star.
it converts
Yes,
character style to a string.
right. Essentially, yeah.
okay.
No. This one is convert string to
String to
character
character
star.
star.
Okay.
So this will give you a character star essentially. But I thought because here is a string, I shouldn't need it. But let me actually check.
So this converts the object, like these are part of the string class. This converts the string class into the C string class.
Right, exactly.
But why are we doing that?
I don't know. That's why I'm going to check. It might not need it. So I'm actually get rid of this.
Because this is already a string, so why are we?
Yes, it must be for some reason. I want to check one thing. Yeah, I don't think I need that. In fact,
So we don't need a
in this case, we don't need that. It's probably in some early implementation I did that. but it wouldn't hurt though, because they will do, yeah, they will do. Okay, so we don't need that. You can get rid of that. It doesn't matter. So any code you can modify just like what I did, whether it's still okay. Okay. All right. So actually I'm making a call with this 6 parameter. Okay, and get rid of C string. We don't need it. Yeah, I just validate, verify it's okay.
If it's already a string, we need not convert it to a C string, right? If it's
Yeah.
already C++ string.
Well, depending on where they're taking, if this place is taking a C string, some of the function they might, if they take if here it says character star, then I have to convert it. I have to use C string. If this is already say string, it's okay. It's actually probably this is better. Okay. All right. So I'm actually making this call like this. So you can see that this call is going to connect over here, right? Any question? All right. Let me actually, before I get into this function, I'm actually want to get into the rest of the code. So what you see is this one will return something, and I put that return into this my v. Is the result of the my v. Let's actually move there. And then I actually print the my v. My v, okay. My v is actually a JSON object. There is a function called toStyleString, means that it will actually print a string representation of the JSON object in a nice string format. That's what toStyleString. If you actually look at this line, you see that there's a function called toStyleString. That's one of the function they have. This is the public JSON value class reference. There's a function there. But that's a minor, this is really just debugging, okay? All right, so then,
This is also member function.
yes, that's a member function of the JSON column value. That's a member function. There was a lots of interesting, useful member function under this class, okay? And then at the end, what I did is I returned the result, right? It's a get distance. What do I get the result? My v to the distance. I extract that particular key called my v distance. I will show you how I put that on the server side, and I extract that value and then interpret that as a double, because I want to convert that, and then I return that double value to whatever called get distance. Okay, my v distance dot s double, and now I want to show you this part is now go back to hw3 client.cpp. So you can see that I'm actually now getting a double from f2.getDistance, and then I toString. I just basically converted to a string that I printed out again. Okay, so that's basically it's doing. Okay, now the only part I haven't touched is hw3 client.h. Now I'm actually looking at this code, this function called Lakshata, the code that was automatically generated. I have the 6 parameter. Guess what? I'm actually going to generate a JSON based on this 6 argument, because you actually gave me the 6 argument. I just create another JSON value object that this is a JSON. I'm going to send it to the other side. And I basically say action, argument, arguments, class ID, class ID. Okay, let me actually do this. I want to see what this JSON looks like. Okay, this pJSON looks like. So I can actually do this. Let me actually change the code. Even though it says I cannot change the code, let me actually change the code. Okay. So what I will do is std cout, and I'm going to do p dot toStyle string. So I basically construct a JSON. I want to print the toStyle string and std end line. Okay, so I'm basically printing whatever they actually send it to the method. Remember, I construct this JSON object p, and then I call this method with Lakshata as the name of the function, and then p is the parameter I'm going to send it. So I'm going to print that thing. Let me try to make it. All right, so I have a client server. Let's see, my server is still running. Let me just
Yeah.
make sure I kill all the program. And where's my server? Oh, my server is still here. Okay, this is my server running. Now I'm going to run my client. Now you see that I'm actually printing the JSON. So whenever I send the message, I actually print this JSON. That's the JSON. I actually send it. See, I got is action, get distance. This is flight JSON, class ID flight, host URL, 8384, object ID, owner VS ID. This match exactly how I call, right? So this is essentially the JSON I just created. So the program, this piece of code that's generated, this piece of a line is essentially generate that JSON. But that JSON got sent to the other. So this is this call method. Okay. So we're actually done with the client side. At the moment you actually call this call method, it's actually being handled by JSON RPC. And JSON RPC will find the server side to actually do the action. Okay. Any question? Okay. Oh, by the way, before we do that, how does he know which IP address and port number? Let me ask you, when I do this call method, I mean, there might be 10 million program out there is receiving JSON RPC. How does this program at this moment figure out the call method, which should be the receiver of this method? How do they get the information? It is. Oh, no, actually not in client.cpp. It's in a different file. The client.cpp doesn't have the direct information. The information is being handled in the shadowfly.cpp. Let me remind you what's happening. If you remember shadowfly.cpp, we have a few parts that eventually will call this my client Lakshata, which will call this call method, but my client is this object. And we actually set it up here. See, we actually create this my client. And over here, we actually have this HTTP client. And this HTTP client was set up with the host URL. So essentially here, where's the host URL? HTTP host URL is here. That's how they pass all the information through this layer and then be able to make that call. So when you do this call method, it's actually going to get to the remote. Okay. So now at this moment, we're done. We actually passed the control to JSON RPC. We gave them the parameter. We gave them the function name. We actually gave them the configuration so they know where to look for the other end of the RPC communication. Any question?
So call method connects from the client side to the server side.
Yes, call method will trigger all the RPC related protocol to actually find. Now they got the information. They will use the information to find the server. Where's the server? If it ever exists, if the server doesn't exist, it will fail. Yeah. Well, okay, that's a good question. Let me actually try this one. So I have a server running here, right? Let's kill the server. And now I'm trying to run the client. You see that is arrow. See, it says client connector arrow live CRL could not connect to HTTP localhost 8384 because that one is not available. That's how it actually used that URL. But if I keep running it, when I bring it back, yeah, it works. Yeah, that's how yeah, there is a lot of option you can try to modify. You can kill this, do that, and see what's the action. See, sometimes the arrow message will help you to understand what's the action. Okay, so that's the RPC side. Now I'm going to move to the server side. Okay, I'm going to move to the server side. So the server side is going to be received is actually under hw3 server.cpp. So to make it more technical, just to let you know what happened is that if you go to hw3 server.h, inside here, there's one part that's actually going to, they call the bind method. It's actually, this is RPC protocol. When you create the server, it will bind this Lakshya method to the program. This is the function called hw3 server Lakshya. So there is a binding about if somebody make a request for this service for the name Lakshya, I'm actually going to call this function Lakshya. Lakshya I, which is this one is Lakshya I, and then it will call this Lakshya. Okay, so it's actually this code. When you create the object, it's actually bind it there. But the real function is defined over here. So this is actually the function when you say this Lakshya is actually going to call this function. But very important, this function is defined as a pure virtual function, which is equal to 0. The pure virtual function means that it doesn't have an implementation. That's why we need to provide this function when we use that. So essentially we inherit from my HW server, inherit from hw3 server, but then we define our own Lakshya over here. And that's why this function is actually here. If I provide it, guess what? Whenever the HW server receives the request, it will actually call this function. It will call this function. And right now you can see that is actually printed out. Let me actually just change this a little bit. Action argument. Let me just print something. Just let you know that why this is what is happening. I'm just adding FFF. G. Okay. Make. Okay. Sounds compile, no problem. Okay, now I'm going to make those two function call from the client side. The client side is the same, and you can the server side, you can see that it's actually FFF. So you know that when you make the change, you know it's actually been calling that particular function. So now you know what we did is finally connect to the server side. So now we just need to worry about what the server side doing. So server side is this function is being called. So inside this function, what I did, I have exactly the 6 argument. Again, action, argument, class ID, host ID, the 6. Now let's actually compare the 6 to hw3 client.h. This 6 order is exactly the same as this 6 order. This 6 argument. Action, argument, class ID, host URL, object ID, alphabetic order 6. So that's exactly the thing with this one. It is exactly the same. So what I'm saying is the compiler, not the compiler, the JSON RPC stuff, the code generator, it will generate the function signature, the client side and the server side, exactly the same. So then we know that's basically from the ecs36b. Okay, so look at this relationship between the ecs36b hw3.json related to the code get generated. Okay, so inside here, now it's your code. Okay, so you know that you provide this function signature to receive the parameter from that call, but anything under here is your code, your response. Let me just explain this very quickly. So what I did is first I actually checked because I want to actually identify to fly object. So I check the class fly, whether the class is equal to fly. Let me actually compare to what I have over here in the hw3 client CPP, because I can now see the code here. So you can see that the class is a flight. That's I try to compare whether this is actually flight. And then I compare whether the object ID is 02 or 03, which is compared to this two. And if this is, if this is a flight, is not object flight 2 or flight 3, I know the object unknown. That's why I'm saying is a class unknown or object ID unknown. And if it's correct, then I would just call F2, get distance, F3, get distance. Let me actually change the code a little bit so you can see that what happened if it's unknown. So what happened if I change this to 04 and 05 and 04? So I change both of them to be a different object ID. So I'm expecting I'm not going to get the result. I have to make my server still running. Yeah, my server is still running. I don't have to rerun it. So I'm going to do client. You can see that the status failed because it says object 005 unknown and object 004 unknown. Okay, so that's how you can see that how it's connected to each other. Okay, so the final thing I'd like to talk about is how is a result being passed back. So in hw3 server.cpp, the same function, you see that the result I got is a D. D is equal to F2, get distance. So D is a double. And how do I use that D is here. You see that this is the place I said distance is a key, colon, to string D, means that I convert that double as a double to a string representation of a double, which means 5.6 or something. And I put it there as a JSON called str JSON. And this particle is essentially convert that string JSON into a real JSON object. So this particle, you don't have to know this right now, but you just use it. If you look at this particle, it's essentially using the JSON library to convert the string into the result, and what is the result? The result is what I'm going to return the result. So essentially what I'm doing is I have a JSON string. I encode it with a JSON V object, and I return that JSON V object. So what is the result? Result is defined at the beginning. You see that result is also a JSON object. So JSON column value. So you can see that JSON under column value is going to be your best friend this quarter, just to let you know, okay? All right, I hope I go through every piece of code from the client side or to the server side. Any questions before I turn off this recording so I can upload? Okay, good. Hopefully you understand with the code, with the explanation, you can actually play around. Okay, I'm going to stop the recording.